differentiate the following functions, and then we're given 4 functions that all involve powers, so we're going to want to use the power rule. Now, let's recall the power rule. It says that if we want to differentiate x to the n power, the result is n, the exponent moves out front, times x to the n minus 1. So the exponent decreases by 1. Let's see how this rule goes into effect in each of these problems. We'll start with f of x equals x to the 98th power. Now this is a power of x, just like our power rule involves. And so in this case, n is 98, and that means that when we take the derivative, remember the power goes out front, so that's going to be 98 times x, and then the exponent decreases by 1. 98 minus 1 is 97. So we've got 98 times x to the 97th power. All right, let's take a look at g of x. Now, g of x is 1 over x squared, but we can rewrite this just as a power of x. It is x to the negative 2nd power. And once we write it like that, we see that we can use the power rule here. So for the derivative, g prime of x, remember the exponent goes out front, so the negative 2 goes out front, and then we've got times x to a power. And remember that we decrease the exponent by 1. If the exponent is negative 2 minus 1 is negative 3. So this is negative 2x to the negative 3rd. If we want to write this without a negative exponent, we can write this as negative 2 over x cubed, or we can put the negative out front, negative 2 over x cubed. Either way, that gives us our derivative. Let's look at the third one. H of x is the cube root of x squared. We can write this as a power of x. You may or may not remember that when we have a root, like the cube root, the index becomes the denominator of the power. And so because we already had 2 as a power, but we're taking the cube root, this is going to be x to the 2/3 power. Now we can use the power rule to differentiate because we've got x to a power. Remember, the power rule tells us to take the exponent and bring it out front. So this will be 2/3 times x to a power. And remember, we have to subtract 1 from the original exponent. 2/3 minus 1 is negative 1/3. So this becomes 2/3 x to the negative 1/3 power. We could also write this as 2 over 3 times the cube root of x, because the negative exponent brings that to the denominator, and a cube root is the same as a 1/3 power. So we're good there. Now the last one, we've got r of x equals 2 to the 50th power. This one is meant to maybe trip some people up if they're not paying attention. There's no variable here. This is not a power of x. This is not x to a power. This is just a constant. It's got an exponent in it. It's a really big constant. 2 to the 50th is a ginormous number, but this is a constant function. And the derivative of a constant function is always 0. R prime of x is 0. That's because a constant function has a graph that is a horizontal line with slope 0. There is no change in a constant function, so the derivative is always going to be 0. And there we go.